I'm Rachel Alexander.
I'm Emily Fleming.
I'm Nate Pfister.
And I'm Eric Verheyen.
And we are one of the Iowa State's Industrial Engineering Senior Capstone teams for the spring of 2018. Due to confidentiality, we have withheld any detail that could identify the company we worked with.
Our client was a metal fabrication plant, and our project scope was focused on the welding cell that is a part of one of the 3 value streams. This welding cell produces 6 different models with 3 different fixtures to accommodate them. The welding cell is the bottleneck of the value stream, and originally this was thought to be because the fixture changeovers were time-consuming and labor-intensive, leading the operator to perform changeovers less often. This causes batch production, leading to the cell schedule not matching up with the paint department, which is the bottleneck of the entire facility. The welding cell bottleneck affects 29 people downstream. Our objectives for the project include reducing the changeover time of the welding cell by 50%, creating a more efficient transition between the 3 welding fixtures, and combining the 2 welding stations into one.
We wanted to get a better understanding of how the cell worked in regards to production and changeover cycles. We started with a work sampling study to show the proportions of time the operator spent on each action. We conducted an observed time study to find out how much time it took to accomplish each of those actions, and we also assessed the amount of feet the operator was walking through Workplace Planner. From the work sampling study, it was found that just under half of the operator's time is spent doing non-value adding or non-value adding but necessary tasks. These increase the amount of movement, which therefore increases the effort required by the operator. The observed time study determined that the cycle time of the cell was 6 minutes and 2 seconds. The team also identified that less than half of the operator's production time is spent welding the components. This uncovered long and unnecessary setup and sanding times. The work sampling study also found that the changeovers take on average 10 minutes and 38 seconds. However, this only accounts for 5.32% of the operator's total time. Within the changeover, the travel and setup is 5 times greater than the physical fixture exchange. By decreasing the amount of unnecessary travel and number of changeover tasks, the operator can easily switch between model numbers and increase the throughput of the cell. After the current state analysis, it was determined that the best course of action was to start with a layout redesign to reduce walking distances as well as production and changeover cycle times. Each of the 7 brainstorm designs was analyzed with Workplace Planner to gauge which practical design resulted in the greatest reduction of walking distance and overall effort. The team came up with 2 layout alternatives and 4 proposed add-on options that they believed would best benefit the operator, the welding cell, and the company as a whole. These options were discussed with the company to select the final design.
The above layout of the current state is a depiction of walk paths and walking distances traveled by the operator. All white lines represent walking to or from stations throughout the cell. This includes transporting pallets of finished WIP to a holding area, as well as transporting the individual units through the welding cell. This resulted in her traveling a total of 10,532 feet per day. This is the future state design the team finalized. The biggest change in this new welding cell is removing the second welding operation and buying a new welder capable of completing all required welds. Some additional features of this new design include moving the WIP into the welding cell and organizing it by model number. Another feature is the blue rack pictured, which stores aside components for the product. This was moved to allow the operator immediate access to the necessary parts. As a result of this new design, the operator is walking 5,434 feet.
The current fixture impedes multiple welding spots according to the part designs. Thus, the team created an alternative support that allows the operator to reach all necessary welding spots, as indicated by the blue arrows. Also, material handling is avoided by the use of a circular carousel. Fixtures will be placed on the carousel with individual pneumatic attachments to reduce changeover by nearly 15%. A welder was selected that is capable of integrating the 2 welding stations. The new welder has a wider jaw and deeper throat so the operator can reach over to side panels. Also, a spot welding tip was added with more surface area to reduce pressure and decrease quality issues that require sanding. The value of the project is based upon savings from reduced changeovers and cycle time, as well as cost of investment into new equipment. Initial investment is $17,000, which results in a savings of $47,450 in the first year.